In this video, we will learn about the machine learning, where the artificial neural network, the supervised one, how the training happens using back propagation. The initial models of the artificial neural network like McCulloch-Pitts model, the perceptron, had very minimal learning. So McCulloch-Pitts model didn't have any learning at all. The perceptron learning is called the Hebb learning. To refresh the McCulloch-Pitts neural model, 1943, it's an extremely simple artificial neuron. The inputs could be either 0 or 1 and the output is also 0 or 1. So each input could be either excitatory or inhibitory. The weights are used to indicate the input, which type it is, and if the weight is 1, it is an excitatory input, and if it is -1, then it is inhibitory input. The calculating the weighted sum, so summation of xi wi, and if the sum is less than the threshold, then the output is 0, otherwise it is made 1. There is no learning, no learning is possible in it. And where it is used for some of the like AND, NAND, the gates, to learn the gates. So if we can see the xi, x1, x2, x3, xn, each connected to this neuron using the weights w1, w2, wn. Similarly for the NOR gate and NAND gate. Now coming to this perceptron, the perceptron will be separating two categories provided they are linear in nature, and it is also called single layer network, just having two layers of nodes, and single layer network having one layer of links between the input and output. Frank Rosenblatt in 1950s invented the perceptron. Let's see the working of it. Several input values taken, x1 to xn. The connection, each of these inputs has a weight w1 to wn, initialized and updated. The threshold unit then sums the weighted inputs and triggers the binary activations. We see here AND or XOR. XOR is not able to be separated because it is not linearly separated. So from the geometrical perspective, the perceptron attempts to solve the AND OR, but the XOR problem is not solved. How the learning happens, if we see diagrammatically, left hand side the input are weighted inputs, then it is summarized. Some summation is done. Then if it is a misclassified, yes or no, a decision is taken. If it is misclassified, we update the weights, and then again it goes for an iteration for the validation whether it has been misclassified or not. Till the classification is correct, it will be iterating, and then it goes to the next sample. So if the number of misclassification is not 0 after training the whole set, repeat the steps 2 and start from the beginning of the training set. So we repeat this step until the number of misclassification is 0. This perceptron training, it's a learning rule. It occurs when the error is made. So the formula is wj t plus 1 equal to wj t plus eta d minus y x. Eta is the learning rate, and the performance measure is given by the cost function, which uses some squared error and computed all over the input-output pairs in the training set, which is denoted by the E. This error has to be minimized. This is a limitation of the single layer perceptron, can recognize only one kind of pattern, which is linearly separable. Diagrammatically, we can see the table and how it is represented using the plot. In the last one, in XOR, it can be separated, but it used two-layer LTU. So it is not one line, but it is using two lines to separate the red points from the green points in the case of XOR. There is a quiz in each category of furniture. Is this linearly separable? The chairs, beds, tables. And what is the problem? They can be linearly separable, but they cannot be separated by a single line. we need 2 or 3 straight lines, and then we can separate each of these categories. So 3-dimensional output vector is required so that more than one output node could fire at the same time. So there are 3 categories: bed, table and the chair. And the neural network will look like this. Coming to the multi-layer perceptron, till now we discussed about the single layer perceptron. In the multi-layer perceptron, it is also called feed-forward artificial neural network. The ANN allows the signal to travel only one way, from the input to the output through the layers. It is extensively used in the pattern recognition applications. Another way of seeing this feed-forward artificial neural networks, where we are having this hidden layer. How this learning happens? This learning happens through the back propagation of errors. The information moves forward, the errors move backward. The feedback connections exist between the neurons of the networks, and they occur during the learning, training and the training stage. So the weight adjustment is fed back to the various layers of the output layer to reduce the overall output error. When the training stage ends, the feedback interaction within the network no longer remains. This is a diagrammatic representation, how the information is fed forward and how the errors are back propagated till the errors are minimized. This is going in a loop. Let us see strength of this multi-layer. In the first row, it is 1 layer. The second row, it is 2 layer. In the third row, it is 3 layer perceptron. So in the first layer, it is not able to solve the XOR problem. In case of meshed classes, so the second, third and fourth column representing some problems like XOR problem, meshed classes and general region. If we see that it's only 1 layer, then XOR problem is not being fixed. The meshed classes also, apart from the B, it is also putting many other pixels in the same category. And general region, it is just taking 1 line and 2 portions it is having. In the 2 layer, successfully it is able to solve the XOR problem by using 2 straight lines. In the meshed classes, we are able to see it is more close to the B category, and it is having an irregular shape and trying to classify the A and the B region. When we are having more layers, and now the 3 layer, then slowly the B is separated out, and in the meshed classes also it is more closer, the classification is more appropriate, and in the general region as well. So the non-linearity increases and it is able to capture the classes properly. Now we will see the step-by-step way how the back propagation happens in using the multi-layer perceptron. Consider one example where input is 0, 1, 2, 3, 4 and the desired output is 0, 2, 4, 6, 8. Model step 1, we will be initializing the weights. Y is output is equal to W of X, and we consider randomly W is equal to 3, Y is equal to 3X. Step 2, forward propagate. So what for forward propagating, actual output is computed by using Y is equal to 3X given the inputs in the left hand side. So the output is 0, 3, 6, 9, 12. This is not equal to the desired output which is mentioned above. In step 3, performance metric of neural network, we need to measure the performance, how it has done at present by computing the loss function. Simple loss is the difference between the desired output and the actual output. The actual output is also called prediction. Absolute error is absolute value of the difference, and total amount of error for the artificial neural network is equal to the sum of squares of absolute errors. Using this formula of sum of squares of absolute errors, we can see given the input, the actual output, sum of the actual output we found in the second column, and the desired output is the third column. We have to minimize this overall error rate for the whole data set. So going forward with the step 3 itself, in the loss function, the absolute error is computed and the square error is computed. In this table, we can see input, the actual output, desired output, target, absolute error and the square error. The square error, total square error, we saw it is 30. The loss function is an error metric that gives an indicator how much precision we have lost and how much we have to be close to the target. Step 4. Now we know that there is an error. What to do next? Next is derivative. That is, we transform this problem to an optimization problem, and this is a minimization of the loss. The objective is loss minimization. But how do we do the optimization technique? The first option is brute force, which is not efficient, and we have to take every step 0.001. Initially we took the weight as 3. Now if we take 3.001 or 2.999, then 3.002. So we are doing a brute force with each and every step, and that would be a huge computation. So coming to the second, where we will be taking the help from the mathematics, that is the derivative of the loss function with respect to the weights. So how much total error will change if we change the internal weight of the neural network with a certain small delta value, delta W. So moving forward, if delta W is 0.0001 for the model y is equal to Wx, now focus on the fifth column where updated W is equal to, so in the updated output, W is equal to W plus delta W. So for the first input 0, nothing changes. For 1, it is 3.001. For 2, you multiply with 2, 6.002, 3 and 4 similarly. Now we measure the squared error. We see that the squared error has increased from 30 to 30.006. This gives us an idea that we should not move towards the direction of doing a W plus delta W, rather we should go with W minus delta W. When we do a W minus delta W and W is equal to 2.999, the error reduces to 29.94. So we are able to decrease the total error. The mathematical derivative is that it will be much faster, more precise to calculate. Check the derivative and check the error pattern. So if the derivative is equal to 0 for loss equal to 0, neural network actual output will fit perfectly the training set. We will reach the perfect model. That is the objective. If W is less than 2, the positive loss function where derivative is negative, an increase in the weight will decrease the error. When W is greater than 2, the loss becomes positive, the derivative is as well positive, and any increase in the weight will increase the loss even more. This is how the learning process happens using the derivative. If we see it diagrammatically, this is the schematic diagram of gradient descent. We randomly initialize the ball of the error function. The learning process acts like gravity and pulls back the ball to the lowest energy, to the ground zero. The global cost minimum is at the bottom tip of this parabola. Slowly it is moving down. The optimizer helps to determine how quickly the model learns through gradient descent. The loss function and the optimizer, this is available in Python, the Keras, for modeling, building the model. We can use this loss function and the optimizer. The optimizer will help to determine how quickly the model learns through the gradient descent. If it is a big learning rate or it is a small learning rate. So this parameter can be tuned. It is important not to get stuck in a local minima. if we see in the diagram, the local cost minima and the global cost minima, our objective is to reach global cost minima. So if the cost minima is stuck at the local and it's not able to come out of it, then we won't be able to minimize the error. And to solve this problem, we have to take a larger learning rate to jump out of the local minima. If we take a big learning rate, we are able to see in the leftmost diagram that the moving forward from the left to the right is a big jump, big step. But when it is a small learning rate, we are going step by step with a smaller steps are taken to reach the minima. Now coming to the fifth step, that is the back propagation. Now we understood that okay, this is the error and this is how the error can be reduced. Now coming to this concept of function composition. What is function composition? For every composition, one is to calculate the dedicated derivative of the composition. So derivative is decomposable, thus can be back propagated. So in the back propagation, we have the starting point of errors, which is the loss function, and we know how to derivate it, and we know how to derivate each function from the composition. We can propagate back the error from the end to the start. Function composition in the first diagram, where input and then the function is 3 dot x, the output goes to the z square, and then the output is obtained. This function composition can also be seen in the second one by using a function called 9 dot x square. Both of them gives the same output. So in this forward pass and the back propagate error, once we know this error E is the loss function, we take the derivative of the loss with respect to the weights. The error is back propagated, so it reaches the box where we have mentioned 2 into W2 into Z. It is the derivative of W2 into Z square, which is mentioned above. Next, in W1x, the derivative is W1. How much the error, how much weights are responsible, how much change in the weights is responsible in the change in the error. Step 6, weight update general rule. That is the delta rule used. Old weight minus derivative rate into learning rate. The weight update methods are called this optimizers, and it can run in 3 modes. Update the weights, say the whole data set can be divided into batches. So update the weights after each batch size, that is called batch learning gradient descent. Update the weight after n equal to 1, that is full online learning stochastic gradient descent. And update the weights after the whole data set has been trained, that is full batch learning. In step 7, iterate until it converges, and we update the weights with a small delta step at a time. It will take several iterations in order to learn. So what are the steps for process of back propagating the errors in order to learn in the artificial neural network? Given the input, forward the calls, compute the loss function, take the derivative of the error function, back propagate the error with respect to the weights, weight update, and iterate until the convergence is done. Same thing in the diagram, it is mentioned. Step 1, random initialization. Step 2, feed forward. Then step 3, calculate the loss function by taking the input desired output, and the actual output will help us to get the loss function, the loss error metric at this step. Step 4, calculate the derivative of the errors, gradient for the last layer, back propagate, and finally update all the weights using the optimizer function, delta rule, and in any there are 3 types of updation. Any one we can use. Some of the case study where we use this artificial neural network feed forward, forecasting photovoltaic output in the domain of environmental science, predicting the magnitude of earthquakes using the multi-layer perceptron consisting of the 3 main layers. There is a feedback neural networks. Feedback neural network also is called recurrent or interactive networks. where signals travel in both the directions by introducing loops. The purpose and the objective is to have a dynamic memory concept where you can have the memory storage, and the applications are suitable for modeling relationships between a set of predictor or input variables, functional mapping problems. Some of the types of the feedback neural networks are called Hopfield network, used for associative memory. Cohen's self-organizing map is a unsupervised learning technique during the training process based on clustering and the dimension reduction. It is used to discover the underlying patterns, underlying structure of the data. Feedback neural network looks like this, where you can see there are arrows going forward as well as backward, and some loops are also existing in this diagram. Whenever we are learning, we have to be sure that the learning is well taken for the classification task. It should not be underfit, it should not be overfit, it should have a perfect fit. So this is underfit leftmost side, overfit, and this is the normal classification. One should aim for a normal classification. The function generated by the learning should not be an example of underfit or the overfit. Coming to the quiz, let's see the answer. So McCulloch-Pitts model does not have a learning algorithm, and perceptron is a linear one and cannot train the XOR. Additional layers provide the network with the ability to learn non-linear functions. This is an exercise for simple image classification. Given this problem, try to draw the graphical representation of the perceptron. This is the answer. The solution you can find out. This is the diagram for the solving the problem. Arrange the milestones in the development of the neural network. The answer is starting with electronic brain, then comes the perceptron, then Adeline. XOR problem arise. To solve that, we have this MLP, multi-layer perceptron. Backpropagation of the error is used for training or to learn. Then comes this support vector machine and the deep neural network. Thank you.